back in May 1977, that was almost 50 years ago, first Star Wars movies came to cinema. And since then, for that generation and many generations afterwards, it was a great inspiration. There are many reasons. Like there are those aliens, many different, from many different planets. Like there are spaceships. They can travel between galaxies and so on. There are lightsabers and fights with them. But one thing that is specific for the Star Wars, there are many droids. And those droids are usually there as some cute little helpers. And this is something that we will speak about today. This is an inspirational session. This session will show you how technology nowadays allows us to build such droids. And this is also something that you can do at home. And this is the way, right? So, my name is Goran Vuksic. I'm originally from Croatia. I moved to Denmark some 10 years ago, spent 5 years there. Then I moved to Sweden, where I live nowadays. I am CTO and co-founder of a small startup called Synthetic AI Data. We focus on synthetic data for computer vision. If you're interested to hear more about that, feel free to catch me later on the after party, and we can speak about that. You can find me on LinkedIn. That's only a social network where I'm actually active. And I usually post about AI, IoT, robotics, and some interesting community events, because I like community a lot. And I'm recognized as Microsoft Most Valuable Professional MVP for AI. This recognition comes because I'm often on a stage sharing my knowledge about AI and Azure, of course. I'm also organizer of the Azure Skåne. Skåne is the south region of Sweden. Usually once per month we have a meetup in one place called Foo Cafe. It looks like this. Like any other meetup, it's free to join. There is pizza, there is beer. So if it happens that you are somewhere around there, feel free to join us and hear about some interesting topics. My story with robotics actually started with hackathons, and this is me some 10 years or a bit more ago. And picture is from a hackathon in Karlsruhe, South Germany. Nice thing about that hackathon, it was organized in a technical museum there. Made it interesting, over 100 participants. Hackathons, as you might know probably, are developer competitions where developers compete in 24 to 48 hours to build something cool. What we decided to build, my team over there, was actually like Alexa was a new device that just came out, and we got one. So we wanted to build something with it, and kind of took different approach. Decided to use Alexa to build, to connect it to electrical guitar. And since this was in Germany, we decided that Alexa could pronounce Rammstein lyrics because it cannot sing, and we will control how it plays the guitar. Somewhere around there, I was always curious toward robotics and stuff, but I think the main things started happening after this, like in my free time, and you can see it pressing some chords here and was hitting the strings. I built after that, I would say, several robots. At that time, my son, he's 80 now, was much younger and much more interested in those things when we were building, some self-driving cars, some projects with Arduino, Raspberry Pis, and things like that. Nowadays, my wife says I'm a big kid, and he's not much interested in that. I'm the one playing with toys. But okay, it's a passion and something interesting. One of the first droids that I started to build was BD1 droid. BD comes from body droid, like a helper droid. They were built like, assisting droids that helps out researchers or explorers in the field, and they can walk around. They appeared in the Jedi Fallen Order and Jedi Survivor. Kind of cute droid, and also later on they appeared in the Book of Boba Fett in the series. And they are pretty cute, and there was no surprise that LEGO decided to make a set with this droid. Assembled, it is like 30 centimeters tall, and 31 centimeter tall, and when I seen this set, I decided, like, yeah, this is something that I need to buy, and not only one, I bought immediately two. That's how big geek I am. But I had this idea, let's use two sets, let's assemble it, like, let's make a bigger one, because 30 centimeters is not so tall. And I had this idea, okay, maybe I can fit something like Arduino or even Raspberry Pi in the head. And you know, those eyes are perfect to put the camera in front, so maybe I can combine something around that. So the assembly started. Actually, let me just point back. There was some hardware bought, like Raspberry Pi, servo motor, LED display, and webcam that was used all together. But you'll see it now step by step. So I started assembling the legs and the body. When you have the instructions with LEGO, it's pretty easy. We all know, read the manual, right, before you go do anything. And but if you're trying to put two sets together, it kind of becomes the mess, especially because you need to balance it out, figure out how this thing will stand on the table. Assembling the head, there was a Raspberry Pi inside. You can see there on the side, over here, and apologies, I don't have some pointer with me, forgot it at home. And there are cables going out, like over here is the camera, actually. I disassembled the camera, put it in the head. And back of the head, I used this dot matrix LED display. It's 4 blocks 8 by 8, which are programmable. Like you can program it separately how you want to turn it on and such. So I tried to recreate this effect that this droid has on the back of the head. And the main idea was, okay, let's put in this servo motor inside, like to be able to turn the head left and right. In this M5 servo is nice because it is LEGO compatible, so you can connect Legos to it, but still it takes a lot of tricks to figure out how it will work, especially how the whole body will stand where the head is moving around, because there is some weight in this head. If you take a look at the schematics, there's nothing complicated over here. I don't know how much experience you have with it, but we have one Raspberry Pi board where we connect this servo motor, and we connect this matrix to it, right? And moving forward, this is the video how it looked finally when it was assembled. Like, okay, it was standing there. Those are the items I was using. And what it was capable to do with the camera, it was capable to record and do the object detection that you will see soon. And based on position, like detecting you can see the LEDs here, detecting where the R2D2 is, it will turn head towards it. Demo is coming here in a second. So I used the small LEGO toy, R2D2, that's the camera. I'm holding toy in my head, right? Showing it R2D2, and it's slowly turning the head in the position. So it's doing the computer vision object detection. We'll dive more into that through some other droids and examples. So this is just the building up story, the history, how it went. At that point, I figured out, I knew it for a long time that Legos are not perfect for this. Like, they fall apart. And you need to either to glue them or figure out like what you're going to do, and then it's one huge mess. And somewhere on the way, when I started with this project and was working on it, I figured out there is a group called Droid Division. It is run by this guy, Dave Moog. He is a designer for 3D prints, and he's taking those droids from the movies and making 3D models so people can 3D print it, actually. This group can be found on the Etsy. He's selling these designs there. Those designs are more like buy me a beer concept. So it's like, pay me $5, you get this design, and you can print it at home, right? And the whole print club, like with a lot of people, they are enthusiasts in this group. They can be found in this Facebook group. And what you see over there on the right is a PID droid. Basically similar concept to BD1 droid. It has a head, right, with a big eye in front, which means we could put some camera in it and maybe control it the same way that BD1 was controlled. And that was my idea, and I said, okay, let's figure out could I actually build the PID droid. Story about PID droid. It first appeared in the movie Phantom Menace in 1999. They are described as cheap, expendable droids designed for maintaining pod racers, those racing cars they have in Star Wars. And it's 1.19 meters high, something like this, with this ability to fold into compact form when it's not in use. I'll show you how that looks like. And what they say about them, they are programmed with a sense of urgency, so they have this minimal logic processor preventing them from completing complex tasks. And I was thinking, yeah, that's great. I'll build a PID droid that can perform complex tasks. I got somewhere, you'll see. This is PID droid by artist Andre Wachel, who created like this, recreated how it should look like and how it's folded in the compact form. And what I found on this 3D printing group was actually pretty cool, like how people print out those pieces, put them together, and get a 3D printed droid, right? So I decided, okay, let's do some 3D printing. But at the moment, that point of time, I didn't have a 3D printer. Got it later on, you'll see. But I reached out to this Star Wars enthusiast, Ermer Tvano, who 3D printed it for me. I, of course, paid him covered the expenses for the materials and such. And I got a lot of those 3D printed pieces that I wanted to put together, but not just to put them together as a plastic, as usually, for example, Lego is, right? It's just a plastic that stands there. I want to make things move, and I want to interact with those things also. And the main idea about the head was to fit this LED in front. I needed to have ability to turn it on and off, so I used some kind of relay. I wanted it to have this ability of computer vision, so I had to figure out, okay, can I fit webcam inside of it? And I found this small webcam that was possible to put in front. And 2 digital servos were put in head because one is moving it left and right, the other one is moving it up and down. And I decided to put in NVIDIA Jetson Ori Nano. This is similar device to Raspberry Pi. They call it Raspberry Pi on steroids. I'll show you the differences soon. So how the process went. First of all, those plastic pieces 3D printed are not perfect. You need to sand it. And that's not really fun because you need to put the mask. Those are tiny pieces of plastic that you don't want to breathe in. After that, you need to paint everything, and usually it turns out to be a total mess, especially for me living in an apartment, and I had to do it in a basement. And yeah, was a lot of problems. I wish I have a shed for those things, but one day. And assembly slowly started, like assembling the legs. I decided to paint it in two colors. Assembled the torso, the body, the head was next. And after putting some electronics in the head, this was recorded the first test run that you can see over here. LEDs are working, changing the color. And I turn it on and off, right? The motors, the head started moving. Okay, now things are moving. We can build something smart out of it. And as you can see here, there's a camera. I was also using the computer vision. And I assembled everything in one blog post on Hackster. Hackster is community for the enthusiasts about robotics and IoT and such. And when people post there, they give you like all assembly instructions, the code that is required to build the same thing and such. Feel free to check it out. Like if you want, it's a great resource to yeah, build some interesting projects. What happened immediately after was that NVIDIA noticed that because I was using their device and for making the head smarter. And they made the interview with me, me the maker, developer, taps, NVIDIA Jetson is force behind AI-powered P-Droid. Marketing, marketing, marketing. Buy NVIDIA Jetson. Yeah, but that's NVIDIA, right? But okay, I was happy about it. Like they are promoting something that I built, and yeah, it's pretty cool. Few more pictures about P-Droid, and people usually ask me, and I got a question earlier when I was saying, will there be droids? No, unfortunately not, because even though it's not Lego, it's really hard to transport. I tried it a few times, and there were so many challenges. First of all, like you need to pack everything in a bag, and now you get to you know, to the airport, to security there, and if you ever get into situation seeing a guy, you know, discussing something with security, and there's bag open like this, and immediately as you move the cover, there's a bunch of wires hanging out, like maybe it's just a Star Wars fan, not some kind of terrorist or something. And funny story about this travel, even without the droid, was I was coming with connecting flight over Dublin. And there was something on the airport that my wife and son were traveling with me now. And we were not able to go immediately to connecting flight. We had to go out, change the terminal, and then go in again and pass the security again. And yeah, my backpack goes into the scanner. On the other side, security guys takes the backpack and approaches me with the question, do you have some kind of lightsaber inside? And I was like, yes, I do, you know. And then things became awkward, like, can I see that? And stuff like that. So yeah, it's fun. Everything went well. This is just a toy, of course, but yeah. So challenges of transporting droids. Like when you bring it to the conference, first of all, you need to assemble it in a hotel. You cannot take screwdrivers with you in a plane upstairs, so only you can check them in down there. You'll forget something, most likely. Things stuck. You know, then you need to figure out, like, okay, maybe I don't have pliers, this or that. After some time, like, it got assembled. This is my co-founder, Sherry. We were holding session at that conference together. Yeah, moment of happiness. Everything is assembled. Let's take a selfie. And then you spend the night figuring out why it doesn't connect to Wi-Fi, you know. And session is in the morning, of course. Going to conference is also a challenge. Like some kids saying, "Mom, that's a killer robot," and I'm like, "It's not." But like, you cannot discuss with kid or taxi driver. Like, don't scratch my seats and stuff. This was from Azure Lowlands 23 in Utrecht. We managed to get it on stage. Was fun. Was challenge, but like I. Highly suggest keep your droids at home when you build them. What we were doing over here, Sherry has on her head one device that is measuring brain activity, and basically based on the brain activity, when she focuses, droid will turn on, and she can move the droid head, moving her head. So let's talk a bit about brain in this droid. We spoke a lot about plastics and such stuff. As I said, 3D printing is a mess. Don't go there easily. Plan it wisely. So a bit about brains and technology behind it. There are several options, like how you can build your droid, and one of them is using Raspberry Pi. That's the cheapest option. Like this Model 4 is around $35 US. That's pretty cheap, like to have this tiny desktop computer, right? And with this, like, you can connect all those motors on the pins over there, connect some other devices here that you would like. But you can also go for some more expensive version, as I did. In this case, NVIDIA Jetson Orinano developer kit. I already mentioned they called it Raspberry Pi on steroids, and the reason for that is it is capable to run AI models on the device. So with the Raspberry Pi, you can take picture from the camera, you can upload it to the cloud, process in the cloud, and return information. So you can take a picture of that R2-D2, figure out where it is in this side view that the droid has, and return like information where to position head. So you send the picture to the cloud, you get information back, and then you position the head. With this device, you can do it immediately on the spot. Difference is like when you work, if you work with those edge devices in the industry and such, pretty much depends like how fast you need to create some action. If you need something to process immediately, you have some conveyor belt that is, 100 items are constantly passing by in a short period of time, then you would like to process it as fast as possible, process it there at the edge. If such a fast action is not needed, you can go by processing in the cloud, sending the data, sending images over there, processing over there. But in any case, like where you will be using cloud is to upload data points there, because over there in the cloud, you will analyze those data points, build your analytics, and such things. Expensive version, let's look at it a bit to see how it works. Under the cooler over here, number one, there is a micro SD card slot. You flash this card, put the operating system on it, put it inside, and you are good to go. It's a small computer that just runs. Pin extension header on that side. This is where you connect the motors or LEDs or those devices. You have some LED that is blinking green when it's working, USB-C port, Ethernet port, USB ports, display connector, and power input, and standard camera connections, same ones as you would use on Raspberry Pi. The cameras I was using were USB versions, so standard USB camera that you probably have at home. Pin layout. You take an image, you figure out, okay, in order for something to work, I most likely need to connect it to some voltage and to the ground, right? And then you usually combine it with the third pin that will send information. Okay, turn it on, turn it off. So simple. If you ever played with Arduino, like that's how it works. For the LED lights on the Droid, like there needs to be this relay in the middle over here, because LED lights has its own source of power, like 3 batteries, and this relay works exactly that. You connect it to the power, red and black line over there, and with yellow you are sending information. Okay, turn it on, turn it off. How complicated the code is to make stuff move and turn it on and off, you can see over here. We have 2, 4, 6, 8, 10 lines of code. Super simple. And with this, we can turn on the lights. The way it works, we need to use this GPIO library. Sorry if it's small, but it's super simple, and I'll just explain it. We define our pin where we are sending information, and now we send on that pin like information. 1, turn it on, or 0, turn it off. And that's it. Our LEDs are working. What we also need in the Droid to make it, now it's blinking, right? We need to make it move. We need the servo motors, and they are used for those movements. One of them is moving head up and down. The other one is moving left and right. In that case, like, you can position it anywhere you like. Similar concept, defining the pin where you are sending information to motor to turn on, and for how much you are turning it on, like how much you are moving it in one or other direction. Pretty simple. Assembling all that, you are getting exactly this. LEDs that are blinking, you are turning them on, and now turning on the motor and moving it up and down. So we want now to make this Droid see. I said the standard webcam, this thrust axis. I chose this one because it looks like the eye, right? I was able to remove this plastic and put it, as you've seen over here, in the front of Droid. So there was some plastic that I just removed and kept the electronics. And yeah, with USB cam, you can use computer vision. You can train the model to run it on the device, or you can do it in the cloud. Same thing. You'll see the boat now soon. So taking a picture, figuring out where I am in that picture, right? Where's the person in front, and then moving the head toward that person. There's many more things you can nowadays do with vision services in Azure. And those things are basically comes out of the box, more or less. There is a lot regarding the image analysis, like it's over 10,000 different objects that you are able to recognize and detect and such. There's spatial analysis, understanding people presence and movement. I could take picture of or record a video of this room and figuring out, okay, how do you move, where you are at the moment. Maybe used in the industry, like, okay, this is the area where no one should be going, so we need to raise some kind of alarm. You can do OCR, optical character recognition. Like nowadays, we take it for granted, the OCR, but we had so many years fighting with it to get it working normally, like being able to scan some handwritten document and to read what it's written, to understand what's written in it, like, yeah, took a while to get there. But nowadays it works great. And there is facial recognition to being able to like recognize the face, some kind of emotions, and so on. A lot of things come out of the box. Azure Custom Vision is a service that's been around for years. They announced they will shut it down in September 28, if I remember correctly, like, but 3 years for sure. This is the service I'm recommending people to try out, like if they never build a model that is classifying some image or doing the object detection. Like use it in 15 minutes, you can train your model just adding few images there and trying it out. You can find it at the domain Custom Vision AI. Reason they are shutting it down, everything's moving to AI Foundry, as you most likely know. We'll touch upon that later. With Custom Vision, building projects pretty simple. You create, click, I want to create new project, give it a name, give it some resource group where those resources will be, and then you say, okay, you want to use it for classification or object detection. What I was showing over here, this bounding box where I'm standing, this is the object detection in an image. So I'm searching for a specific thing in the image and I want to see where exactly it is. That's object detection. Classification, on the other hand, is saying what is the most represented object in the picture. For example, having like pictures of cats and dogs, like is it a cat or dog? That is the classification. When creating the project, you can define some domains like this general domain, or you want to detect logos or products on shelves. And you have also these compact models. If you train the compact models, you will be able to export it later. So you can train the model here, export your model, and run it on the device. So just download the file, put it on the Jetson, and run it there, if you like. Or you can use the API over here, as you'll see soon. This is empty project. So first of all, I need to add some images. So there are two options, like clicking up top or over here. I click Add Images. I add some images of forks. Those images are untagged, right? We want to tag them to explain to Custom Vision what it is in those images. So if we are doing object detection, we need to draw a bounding box exactly where this object is placed, right, in the image, and we need to give it some name. So this is a fork. In the top, we need to go one by one image and do this manually. In the top, we have option to train, and yeah, after some time, like 5 minutes or so, you'll be able to train the model. Limitation regarding object detection, you need to have at least 15 images of some object that you want to recognize. More images you add, better will be recognition. Also, that object should be in most likely in different environments. But if you are setting up your droid, building it at home to recognize something in your room, you can take pictures with your cameras and annotate those pictures. Same way I did for that R2D2 Lego. With this model, you have option publish, which means it will become publicly available. And over there on the right, there is also export option. If you want to download this model and, as I said, run it on some device, such as NVIDIA Jetson. And you have, once you publish the model, you get the endpoint that you can access with your prediction key, and you can send this endpoint location of the image if it's already uploaded the image, or if you have an image file, you can set this body to the send it in as image file, right, to the endpoint, and you will get result. You will process it and get the location of specific object. So it's actually, I think, pretty simple. Like, if you think about it, how droid that moves the head and recognize the objects work. We had 10 lines for controlling the lights, 10 lines to figure out head movements, like where we need to move it, and few more lines of code, like taking a picture from the camera, uploading here, processing and positioning the head. Or, as I said, export the model and run it locally. When I was building this, like, as I said, I built it, I took it to some conferences. Later on, I just held the sessions about it, how this is built, inspirational sessions and such. And somewhere on the way, Duckling Droids appeared. First, they were presented in 23. They are built by Disney Research. They unveiled them on this international conference on intelligent robots and systems. And Disney, who owns the right for the Star Wars, has this huge and unlimited funds to build crazy stuff. And what they decided to build is actually a droid that you'll be able to see here. This is a bit this is early prototype. That's why it's white. It's called Duckling, and walks on the two legs, capable of moving the head. And now you'll see how it works. It balances pretty well, being able to avoid obstacles and such. And as you can see, it has those funny, cartoonish movements in the whole story. Turning on the light, walking through the forest. I think that's a pretty cool thing. They built it in 3 colors initially. Maybe, as you've seen, it moves like a duck. 3 of them in orange, blue, and green. Maybe you know these guys. So Disney is kind of overlapping and connecting all those things and such. So idea was behind that, but also if you look at the head, you remember the BD1 droid where we started our journey and story about it. That's the head of BD1 actually when they went for it, and why they made these robots droids. They wanted to build it not just to move around and to walk. We achieved that, and we've seen robots like that. But they wanted to build it so they feel like characters. And these droids are, as they are saying, meant to make people smile, laugh, and connect, and not just impress with the technology. So they should be capable of interacting with you and yeah, in a fun and interesting way. And they have this idea that robot can approach you as a duckling and look at you with some kind of personality, and you can interact with it. And they are designed for the Star Wars Galaxy Edge in US, like those roaming companions. So they walk around this amusement park and entertain people. They have few people going with them just in case, you know, even though they can avoid obstacles and stay on the ground, people don't do crazy things. Robots will not do crazy things. But yeah, they are these small 2-legged ducklings, and they interact in a cute way, moving their head and yeah, moving the ears and blinking the lights and so on. What Disney is saying, like they had the secret sauce of making them playful and alive in a way. There were people working on those animations, training the models how to express the feelings through the moment in different situations. And AI is behind it, and it allows it to move freely in the world. And yeah, what also they say, like, if you combine art and science, then you get the characters you believe in, and you get the walking droids. They are also like announced recently. I think I don't have it here in the slides, that the next Mandalorian will feature them somewhere. They'll be walking around. So basically, they are not using just you know, some toys someone is moving, like when those droids are there. Like, they are using fully functional droids in the movie scene, actually in the series, right? And this is the first time the robots are not just being functional; they are adorable, believable, and yeah, shows how this storytelling can make this advanced robotics feel natural and fun, and definitely opens the doors for this innovation in the theme parks, museum, and event homes. I don't know about you, but me as a kid, I always wanted something like this to have it around, even nowadays when I'm grow up. Okay, so what's the hardware behind it? NVIDIA Jetson that you've just seen. So that model that you download and run, that's basically what you can make it move this thing. It has actually two NVIDIA Jetsons. One is used for coordination of the movements and such. The other one is used for the vision. Disney published some research papers on this topic, so that's why I know. And yeah, this is one platform with two legs that features a lot of motors, features a lot of LEDs and cameras and different sensors that allows the movement and walking around. Since it's NVIDIA, is it playing? It's not playing. Since it is NVIDIA Jetson, Jensen is often on the GTC conference, taking them on the stage, showcasing how they work and such. And yeah, because it's really interesting piece of technology. And when I see this, guess what happened? Pen and paper happened. Like, let's go. So like, trying first to figure out, okay, how this whole thing moves, because the robots I was building so far, like, they were just standing. I've seen some people in a P-Droid implementing some motors to move the hands, but like, you still need to have the body fixed and such. So making a robot that actually walks is a bit of, yeah, challenging task, but also making it playful like this. My P-Droid had pretty, you know, hard movements, like not nice movements like this and things like that. And yeah, started figuring out the things, and I was thinking to myself, okay, let's try to build something, but let's not go crazy into 3D printing and all this process. Let's try to keep it as simple as possible. And I went for paper, plain paper. This is something you can use to build a robot, actually. And this is paper cut like out, and I have some Legos over here for the ears, like to have those antennas. Inside of it is the motor that will turn them around. That's the first thing I actually built, and added functionality to the ears. Yeah, starting the program there. And what I figured out over here, like, yeah, those ear movements actually give it some kind of personality, which is cool. After that, I moved into setting up the torch, the light in front. Those are the head movements, right? The motors are moving the head and up and down and using the torch. And adding the computer vision to it, like adding the camera, I decided to program some interaction with that that robot the way I'm imagining it. And this interaction went with some following actions. Now I'm turning it on, and now I'll turn on the light. You can see light going on here. Then turn off the light. Then I'm saying, look at here, like it's waiting for a command. And then look here, like position your head in this direction, right? So basically it's detecting, okay, do I have my palm open? Is it closed? Like if I'm pointing at my eyes, like, okay, it's waiting the next instruction, because next instruction is figuring out where my finger is pointing, because that's where the head needs to be turned, right? So just to play it one more, since now I explain it, will be much more understandable, right? Positioning, and okay, light on, light off, camera is there behind the robot, not in the head itself. Because it was just paper, and camera is heavy, right? So if you want to add camera to the head, you need something more solid. So you remember that story when I said I will not go into 3D printing again, yeah? Right, so 3D printing is a process where you spend a lot of time like this. Basically, that's your 3D printer, and it's just, yeah, slowly going around, and you need to pay a lot of attention to make sure it ends up correctly. After some time, you get your pieces. One thing about those pieces, like in the process, like process that you see in the head that I built, and this, all this takes some time, right? It's not super complicated, but still. In the meantime, what was happening on those online groups and such, there is a great community. People already started 3D drawing, designing this droid. So I was able to find the files, and yeah, easily 3D print them, yeah, one by one. And okay, then you start slowly with assembling. You need a lot of paint, different colors and such. I decided to go for this white, gray, and red version, where you paint those parts needs to figure it out. This is more assembled, like over here. This is basically a small LED torch that you can buy in any store, just disassembled, and battery is positioned inside of head, taking the wires to the battery to have the power. You can also see that there are eyes over here. Those are LEDs, but these LEDs in this case are the ones from you have in your smartwatches. So if basically on those LEDs you can program anything you want, right? Any kind of, yeah, drawing and such, figure out how the eyes will look like. The neck itself, last time we had 2 motors, now there are 3, because this head, beside going left and right, up and down, can also tilt to make those funny interactions. And then you also have the motors for the ears that are moving. The whole body, the way it's built, is it needs 11 servo motors like this. Those servo motors are originally used in those walking dogs. You've seen the Boston Dynamics dogs, right? You know what I speak about. Like those kind of motors are used for movements. The way people design this Duckling is that you can either build it purchasing 11 of those motors, or you can 3D print it and make the whole thing static. And that's what I was after, because like making head and interactions is something I want to focus first. And then there is a tiny detail that this motor costs $550 US, and you need 11, like $6,000 US. I still haven't found a valid way to explain it to my wife. Let's say it like that. Why I need to purchase such things? Maybe one day we'll see when the whole thing will be fully functional and assembled. But like Even though like there's always the option to build the static things and focus on some parts there that you want. And it's not just about, you know, making it computer vision to be able to see. Like you've seen in this example over here, you can interact with it. You can interact via the computer vision, figuring out, okay, this is my open hand, this is closed, showing the eyes, showing the finger. But those are limited set of actions. Like what we see nowadays, and we most likely use it in everyday life, is large language models, which we can utilize for those things. So basically, you can easily connect microphone to your droid and make it accept the voice commands. Those commands, you can translate the voice to text, send it to the cloud, process it with large language model, and return it back to some command to the droid. Whole this thing is about your imagination. And as I said in the beginning, idea of this session is just inspiration to kick you off to go and explore such services to figure out, okay, what is out there. And what is there, like what you can do is a lot. You can do a lot with the speech, converting like this speech to text, also text to speech. Robot can speak back at you, right? And can also do the translations. Yeah, a lot regarding the language, the vision, and so on. This is all you can find in the Foundry, and pretty easily with examples over there to start it to create some, yeah, some models as you imagining that those droids will work. Because, yeah, Disney might set the direction how they imagine it working at the park, but maybe for me at home, I would like to be able to say, okay, please publish that blog post and go bring me a coffee. Because that's my droid, right? I can do whatever I want, and so why not? There's a lot of models in the AI Foundry that you can already use out of the box. I suggest that you try it out. And this is a platform that like combines all those models, tools, frameworks, and governance into a unified system for building those intelligent agents. Because this is where we're going with AI, building the agents that will be capable of making decisions, invoking tools, and be part of some kind of workflow, right? And being able to yeah, coordinate this droid maybe in your home environment, maybe outside. Your imagination is the limit. This is, as I showed you a lot, here is huge part is playing community. Join the community, be part of that community. By the way, this is a community organized event also. In the community, you'll find a lot of cool things like this is, you can buy this droid from Hasbro, like build one, but you can also 3D print it. That's the small Lola. You can do the modifications to it. You'll find all this in those droid builders community. The one I showed you on the Facebook is not the only group. There are other groups also, and people like to collaborate around those things, building small droids, building bigger droids, even bigger droids. Maybe something you can do in your retirement, build your droid, why not? Look at this guy, awesome. Yeah, and some pretty cool modifications, coloring stuff, adding the electronics to it. Not everybody's expert, you know, in building an AI model, or not everybody's expert in creating a 3D file or how things will work, but people exchange knowledge and learn from each other. So someone trains the model, okay, how it should interact with people. The other one makes some programming language, okay, how some servo motor should be turned on and on. And yeah, it's one big happy community. That's with Groku, Baby Yoda, right? Or their version. Yeah, usually people display them at Comic-Cons and such, but many of those have them at home. As I said, it's not so easy to transport, but overall, you know, people are happy. people enjoy it. Look at his face. It's amazing hobby to have, and really a lot of different droids that you can build, and some great people out there, or people with a lot of free time that can build those kind of things. One from you know it from Steve Jobs, but yeah, always my favorite: stay hungry, stay foolish, stay curious, build things. Curiosity will drive you forward. That's how you learn things, and that's how you can yeah, progress. So I would like to say thank you, and may the force be with you. So thanks again for joining this session. Yeah.